Let's discuss number 9b. So you are given the curve and the area shaded in blue color. So let's read the question. So the region bounded by the curve and the straight line AB is revolved 360 degrees about the x-axis. X-axis, calculate the volume in terms of pi of the solid of revolution. So the keyword is volume, right? We are asking to find the volume. So let's highlight the keywords here. And revolve 360 degrees. So first of all, we need to solve the point A and point B. When we see two lines intersecting, we always use a simultaneous equation. So we sub 1 into 2. Substitute 1 into 2, so it will be x plus 4 over x equal to 5. Then we times the x squared plus 4 equal to 5x. That is how you cancel out the denominator. You times the x here, times the x here, times the x here. Be very careful. So minus 5x minus 4 equals 0, and then you factorize to get the point of intersection. This is plus 5, right? Okay, so this is minus. Alright, so we double check so that we won't have careless mistake. Okay, this is minus, this is minus. So we have 1, x equal to 1 and x equal to 4. So obviously here it will be 1, here will be 4, right? So here will be 4, here will be 1, logically. Okay, then how to find the y? We can substitute 1 into here. 4 over 1, we can substitute into any equation because it lies on the two line. So here will be 4 over 4. Logically, this is 1, this is 4. Okay, now we're going to find the volume, right? So we got a point A, which is 1, 4. So let's write down point A is 1, 4 and point B is 4, 1. Now we're going to find the volume bounded by the x-axis. Alright, revolve about the x-axis. Okay, so what we need to do is, let's figure out if I'm going to rotate this line, this purple line, I will get the volume generated about the x-axis. It looks like this. So you can start to figure out the shape of the volume. Is almost like this. Okay, so this is the 3-dimension shape. So this one, it should be a solid generated. So I just sketch roughly. This is the shape of the solid that will be generated. Okay, so it looks like indefinite shape, so we have to use integration. So let's use integration to find the volume, which is in purple color. So it's under this line. So that means we are going to express y equal to 5 minus x, right? So volume is pi y squared dx, right? This is a formula. And the boundary is from x equal to, we have 1 here, 1 to 4 for this volume under. Okay, that is 3-dimension. Okay, so 1 to 4, integrate 1 to 4, y squared. Now we need to substitute 1 to 4, 5 minus x squared dx. So still remember we have one formula. If you can't, you have to expand. but I think I will use this formula. I take the power plus 1 be 3 over 3, and then here there is a negative, right? Be very careful when you use the shortcut formula, negative 1, right? And then we have to substitute the limit from 1 to 4. So the volume is pi. There's a negative 3, right? I can bring out the negative 3. 5 minus 4 power 3 minus 5 minus 1 power 3. So I'm expecting a positive answer. This is 1 cube. This is 4. 4 cube will be 64. 1 cube will be 1. So I got the pi, negative pi over 3, 1 minus negative 63. So the answer is 21 pi, positive 21 pi. But then I have to minus out the volume, which is for the other one. I'm going to show you this line. Okay, if I'm going to rotate this line, the blue curve, this blue curve, it will generate this area, this area. If I am going to rotate this area, I will get the volume for this blue area, right? For this blue area. Okay, so I'm going to rotate this area about the x-axis, and I will get the shape something like this. Something like this is a 3-dimension. So okay, so it's a shape something like this. Okay, right, so this is a shape of the curve that I'm going to rotate about the x-axis. Okay, this is the volume that will be generated. Let me use yellow color to show you the shape. So this one is, I should draw an oval shape like this, and here will be like this, something like this shape, the shape like this. Alright, so we are going to find this volume. It's a 3-dimension volume. Okay, so let's use the integration. So the volume for the blue one, we will use, let's use a blue pen. V equal to pi integrate for the curve. Where is the curve? The curve is y equal to 4 over x, right? Y squared dx bounded by x-axis. So we need to square the 4 over x, the whole thing, square dx, and the limit still from 1 to 4, 1 to 4, right? So let us simplify first. For volume number 2 is pi integrate 1 to 4, 16 over x squared dx. Okay, so we will actually try to factorize the 16 out. Is okay. 1 4 x negative 2, right? Have to bring up the power. Now let's simplify. So the v2 is 16 pi integrate x negative 2 plus 1 negative 1 over negative 1, and we have to substitute the limit for volume. v2 is 16 pi negative 1 over x from 1 to 4, 1 to 4. So we will expect the answer will be positive. Okay, we have negative 1 over 4 minus will be plus, or else we can take out the negative. If you think you are very confused, this negative, it can be taken out first, right? Up to you. But anyway, you have the answer, which is positive 3 over 4. So the answer is 12 pi. Alright, for the blue one. So the answer that we got is a difference of 21 pi minus 12 pi. So volume for the shaded region is 9 pi, right? The answer is 9 pi. So that's how we solve it. So make sure you be very careful with the integration, especially when it involves negative. You can always make the negative outside of the bracket, but it's okay here. You make sure you put a plus here so that you won't confuse. Okay, that's all my sharing about how to find the volume for the curve. Okay then, bye bye and have a nice day. First of all, we have to solve the equation simultaneously to get the intersection point A14 and B41. So we solve the simultaneous equation, 2 marks, and integrate the curve, this curve, the line on top, the curve on top. This one is a below one, right? So we have to make sure we integrate correctly with the limit correct, and then we have to use the right formula, y squared dx, that is a pi, and then you find the difference of the volume between the two curves. That is your answer, 9 pi. Alright.